So hello everyone, this is one more interesting video that is related with the how to remember the Igneous texture from the exam point of view. Okay, and if you learn something from this video, try to share this video with your friends and try to discuss amongst each other also after that. Okay, hope you learn all these textures. Okay, very easily. Okay, these textures are not very difficult. Okay, so I'm using this triangle for this, and on the one hand I'm writing k Felsper. Okay, and at the one hand I'm writing plagioclase, and at one hand I'm writing quartz. Okay, so I'm drawing one circle here. Okay, for easy understanding, and one here. Suppose this is I will make one, choose different colors for this so that suppose there is one more crystal like this of K felspar. Okay, this crystal, suppose this is a crystal of plagioclase, and suppose this is a crystal of felspar. Okay, if we are getting, and we know that here plagioclase is 100%, here plagioclase is 0%, and here it is 0%. Okay, now suppose this is our plagioclase. Okay, and in between this we are getting this much K felspar. Okay, what I mean, if we are getting plagioclase, within the plagioclase crystal we are getting suppose within the plagioclase, this is a plagioclase crystal, and within the plagioclase crystal I'm getting what K felspar. Okay, then we call this texture as a, okay, it means K felspar is present within this. Okay, then we call this texture as a antiparthite. Okay, I will write A. Remember this, A is also given a sign of arrow. Okay, it means K felspar is present within the plagioclase crystal. Okay, now if I will change the color. Okay, now if plagioclase is present within the K felspar, then we call this texture as a, see there. Okay, my doing it like this. Okay, okay, so it is very easy to remember partite and antiparthite texture. Okay, now if I'm giving some other color to quartz. Okay, now if within the plagioclase we are getting the now if we are getting quartz within the plagioclase. Okay, suppose these are the quartz crystals. Okay, then we call this texture as a myrmecite. Okay, and if the quartz are present within the crystal of K felspar, Then what we call this as a granular texture. Okay, sorry, graphic texture. Okay, call this as a graphic texture. Okay, and there is one more, a granular texture. When quartz will change the color so that it is easily understandable for you peoples. When both the crystals, okay, if there is intergrowth of both quartz and alkali feldspar equally, okay, equal amount, okay, almost equal amount, then we call that texture as a GRANO fairy texture. Okay, okay, 50-50, almost 50-50. Now the next is this one more texture that we call as a SPHERUL spherulitic. Okay, is like this. Roughly I'm drawing. Okay, it has a radial intergrowth. Okay, fibrous mineral. Okay, and these fibrous minerals are generally cave feldspar. Okay, generally. Okay, and quartz generally. Okay, and it is present in the devitrified silica volcanics rock. Okay, hopefully this much is okay, easy to remember. The next texture is Rebagebe. Okay, we are getting cave feldspar, and that is surrounded by plagioclase. We call this texture as a Rebagebe texture. Okay, we want to just remember K is present within the center. Okay, okay. Here 50-50. Okay, they are not forming a outer quartz is not surrounding the K or K is not surrounding the quartz. Okay, they are intergrowthing each other. Okay, but in this case K feldspar will form first and then a rim of plagioclase will surround that. What are the conditions? I'm not going into that detail. Okay, otherwise the video is going to be longer. Okay, I'm from going with the exam point of view, for the objective point of view mostly. Okay, so next section I'm going to talk about the variolated texture. Okay, here it is. I'm trying one surface. Okay, so that is going to increase, and I'm getting small circular shape. A sphere. It is a kind of spherulitic texture. Okay, it is sphere shape. Okay, and we are getting. If I will zoom it out, we are getting a radiating plagioclase feldspar. Okay, or diverging plagioclase feldspar. Okay, If you know the meaning of converging and diverging, you can easily understand this. Okay, and it is generally developed in basalt. Okay, there is one more texture that we call as trichitic texture. Okay, in this texture, you know, if we consider a basalt, okay, volcanic, okay, the basalt is flowing and the plagioclase layers are, align themselves, okay, and we call it as and that happened due to the flow of the lava, okay, and we are getting some plagioclase layers like pattern, flow pattern, okay, and then we call this kind of flow pattern of plagioclase, we call this as trichitic texture, and is common in basalt also. Okay, so Arapagabe is a overgrowth texture, and Verulite is also diverging from plagioclase from the center. So up to this, hope it is clear. Now I'm going to some other textures. Suppose we have a pyroxene grain. Okay, this is pyroxene grain. This is bigger pyroxene grain. Okay, and this is smaller pyroxene grain. Okay, and this is also a space that is created, and here also we are getting a pyroxene or olivine. Okay, and there is one more texture. Okay, so now if the pyroxene is surrounded by plagioclase, okay, suppose these are the plagioclase layers randomly, okay, but okay, if the pyroxene is surrounded by the plagioclase slats, okay, bigger pyroxene crystal, we call it as a ophitic texture. Okay, and if the small grain of pyroxene, okay, are partially surrounded the plagioclase slats, okay, it is also randomly, okay, small grain, but okay, small crystal, okay, we call this as subophatic. Subophatic. And if the uh, plagioclase, the interstitial sites is created within the plagioclase, okay, lots of plagioclase, and the space is created within, okay, that space we call as the interstitial, okay, and if it is you know uh, it is well surrounded by the, it is pyroxene but it is well surrounded by the plagioclase layers, we call it as a nisophotic, okay, and if the interstitial site, this is interstitial site that is created within the plagioclase layers, okay, pyroxene or olivine if present and surrounded by the plagioclase layers, we call the interstitial that is created, we call this as intergranular texture, okay. Intergranular, okay, and if the plagioclase layers in which the interstitial space is created and filled by which material, glass, glassy material, okay, we call this as a cryptocrystalline, okay, glass or cryptocrystalline material, okay. call this texture as a interseed. Okay, so in this, so next going to the other textures. So in general, apocalyptic, then this variolites, and all of these are generally developed in the basic rocks. Okay, and the rest of these are developed in the igneous felsic rocks. All these are igneous rock, but developed in the felsic rock. Okay. Now I'm going to talk about the orbicular texture. It is a kind of ring. Okay, but the crystals that are present within it are radiating outward. Okay. Okay, and it is generally developed in the igneous rocks. Okay, and in spinifex structure it is sudden quenching of the olivine. Okay, and it is present within the ultramafic rocks. Okay, and it is particularly developed in only one rock, that is comatite. Comatite. Okay. Okay, that are of Archean age. Okay, after that these textures are not developed. Okay, because these textures need a particular not particular but fixed amount of MgO. Okay, and that in the magma chamber. Okay, because in the Archean period the crust thickness is not that much, and the MgO ratio of the melt is going up to that concentration. Okay, otherwise nowadays in the magma chamber the you know differentiation took place. So due to that the MgO ratio is not going up to that range. Okay, so comatite are the only rocks that are present within the Archean period. After that it will not develop. Okay, so next texture is cumulate texture. Okay, and the cumulate textures are developed in the earlier phase of the crystallization. When the crystallization start place, okay, the crystallization took place within the melt, that the crystal that are build or segregate and form a layer. We call that, due to the gravity. Okay, gravity settling, we call that texture as cumulative texture, and it is also developed in the ultramafic rocks itself. Okay, and we are getting the chromite deposits, other things are related with this. Okay, now next I'm going to talk about the porphyritic. Okay, with a simple word. Okay, suppose this is a crystal. Okay, we call this crystal as a phenocryst. Okay, if the crystal is surrounded by some other material. Okay, finer material. Okay, we call this texture as a porphyritic texture. Okay, and this surrounding material we call as a ground mass. Okay, uh, what are the main reasons? Okay, why the bigger crystal is in the center and it is surrounded by the finer material? Okay, I will tell you. Okay, But before that, if the bigger crystal, that is phenocrystal, is surrounded by the glassy material, okay, ground mass, if it is glassy, we call this texture as a which texture? This is porphyritic texture. This is vitrophyritic texture, okay. And if the bigger crystal is surrounded by the fine material, okay, but there is a presence of some other minerals within the phenocrystal, okay, within the crystal, okay. Then we call this crystal, that bigger crystal, okay, that is surrounded by the finer material, okay, we call this as a polyclitic texture, okay. And what are the reason for this? And we call it as a polyclitic texture, okay. But this phenocryst, now we are not calling it as a phenocryst, we call it as a oikoclastic oikocryst, okay. Okay, now one by one I will explain, okay. Okay, if you look at the porphyritic, within the crystal we are not getting any other material, okay, that is present in the surrounding or some other material, okay. It means this crystal is developed later. Now I'm going to tell you the difference between the how this structure will develop, okay, a little bit, okay. If you look at this porphyritic texture, if you look at this porphyritic texture, the bigger crystal will develop first in the magma chamber, okay. Then the after the development of the crystals, bigger crystals, then the magma is again pushed, again rises upward, okay. And if it is rising upward, its temperature and pressure condition changes and depth also changes, it cool is at a faster rate. Only then this type of phenocryst will develop. This is one condition, okay. There is one more diagram I will correlate. First I will do it by itself, then I will explain with the diagram, okay. Okay, now if we look at the polyclitic texture, first in the magma comes up and it will start cooling, and some smaller crystals are developed, and then again the magma is going down due to tectonic forces, okay, going down, and then develop bigger crystals on that, the smaller crystals that includes that smaller crystals, okay, that are developed, okay. Then again that magma is coming up and we are getting the ground mass that is finite in nature, okay. First magma up, then magma goes down for making bigger crystal, then it again coming up for surrounding 500 material, okay. In this case magma only comes up, okay, for the final material. This is present, this formed at a particular depth, okay, bigger crystals, okay. Now there is two more terms, xenolith and xenocryst, okay. This xenolith is a country rock and this xenocryst is a foreign inclusions, okay. This is gravity settling. Gravity is settling. Okay, there is one diagram I'm going to try to explain you. This side we are getting temperature, increasing temperature, and this side we are getting rate of cooling. Okay, changing the color so that it is easily understandable. This is one curve. This is another curve. Okay, and this curve is for nucleation. This curve is for nucleation. Okay, and this curve is for growth. Okay, I will explain. Okay. Okay. And suppose these are the three conditions: T1, T2, T3. Okay, if the magma comes directly on the surface, okay, its temperature is going down and its rate of cooling is also going down. Okay, it means sudden cooling took place, and if sudden cooling took place, no nucleation and no growth of the crystal will took place. Okay, obsidian like texture, obsidian like rock will develop. It is a glassy nature. Okay, and suppose uh, this is what temperature T3, and suppose if a magma comes and it will reach the temperature T2, what is going to be developed at that time? Okay, uh, we are getting the nucleation that are growing. Okay, I mean the crystals are going bigger and bigger. Okay, and at the growth stage, it means that the crystals that are nucleation that are developed, it is growing. Okay, because the growth and the nucleation is almost at a similar rate. Okay, now if we are talking about the T1, okay, here the nucleation is less, growth is also less. Okay, just shifted this to here. Okay, for better understanding. Okay, here the nucleation rate is less than the growth rate. Okay, it means the nucleation nucleation that developed now, that is growing itself. Okay, that is growing itself. Okay, but if I will draw here, the growth rate is very less of the crystal, but nucleation is so. Now at temperature T3, okay, nucleation growth is not there, and growth of the crystal is also not there. It means what kind of rock it will develop? It will develop at the surface of the surface. Okay, near to the surface, and we will get obsidian like rocks. Okay, which is glassy in nature because nucleation is also not present there. Okay, and if I will look at this part, if I slightly shift this to here. Okay, T2 for better understanding. Okay, here the nucleation rate is more, but growth of the crystal is less. Okay, and growth of the crystal is less. Okay, so then it means it is basaltic in nature. Okay, because pelagic crystals are very less within the basalts that are developed, but it is surrounded by a fine grained rock. Okay, that that crystal that nucleus is not growing up to the crystal stage. Okay, and but if I will shift this for better understanding, okay, if I will shift this here we're getting the nucleation rate is less and growth rate is more because temperature is high now. So so now if we take try to shift this, okay, a little bit, okay, we consider these points, okay. Here at this particular temperature that is higher, and here the nucleation rate is less than the growth rate, okay. Suppose the nucleus that are developed, it is growing, okay, only then we will get bigger crystal, okay. So now just imagine the growth of the crystals are bigger in nature, okay. It means it is higher temperature and with depth, okay. So now try to correlate some of the texture with this so that we will get a better understanding, okay. At temperature we will get the phenocryst, okay, and suppose the magma is pushing upward and it will reach the temperature T2. Now the growth of the crystal is less and the nucleation rate is more, so we will get the porphyritic texture. So now reverse, if we will get the nucleation more here and growth of the crystal is less here, okay. First the magma will come up to these steps and then it will go down where the nucleation rate is less and the growth of the crystal is the more, then again it is reaching up and we will get the surrounding, we will get a polyclitic texture in this way, okay. T3 will represent generally the basic group and the T1 generally represent the coarse nature rocks, okay, that are generally igneous rocks, okay, that are acidic in nature. Okay, hope hope you learned something from this video. Try to share this video with your friends and try to again I'm saying that discuss with your friends, okay. If you like this video, then put the like button, and if you if you have any doubt or any question related with this, you can put all those questions in the comment box. I will try to give the answer.